Good evening. Yes, could you please give me a green check? Thank you, my friends. If you could you please give me a green check? Thank you. Great. We have 12 of you tonight. So guys, JC, if you can hear me, could you please give me a check? I need to hear from all of you. Dan, Matthew, perfect. Dan, our friends, if you guys remember, last week we talked about cables, and we talked about MC cable, AC cable, FCC cable, SE cable, USE cable, and NM cable, of course, notoriously famous Romex. And I hope it was interesting, guys. I know a lot of you work with some or all of these cables. Talk about installation requirements for these cables and sizes and support and so forth. So we have done in the past, guys. What I usually do, I go review the quiz that we have done, and then move on to our subject for tonight, which is basically conduits. Our subject for the night is going to be flexible conduits, and you can kind of ignore that word non-flexible. So we're going to be talking about conduits and tubing. Conduits and tubing. I hope it will be interesting. Talk about construction of conduits and tubing, guys. Original conduit, intermediate. We will talk about ENT, EMT, PVC, I believe, and different characteristics of these conduits. Where you can use them, where you can't use them, how to support them, and so forth. With this, my friends, I'm going to be referring to the NEC Code Book 2008 with some modification as needed from 2011. Okay, start, guys. So this is what we're going to be doing tonight. What we have done last week, if you guys remember, we did the cables. Next week, we're going to talk about raceways, and I believe the week after we'll talk about flexible conduits. Flexible metal conduits, flexible non-metallic conduits, liquid ties, and all this good stuff. So from now on, guys, the coming classes, we'll basically talk about wiring as we talked wiring methods. So we talked about the cables, the most commonly used wiring methods. I'm going to argue this, it depends where you are, but for the most part, the most commonly used wiring method is the cables. It's easy, cheap, no big conduits, nothing. And get into the conduits and advantage of the conduits. Anything else about what we covered last week? Any questions I covered last week? Dan and Matthew, my friend, I need you guys to be with me. Okay. Okay. Any questions, guys? We'll go over the quiz as I said, and I'll flash the answer. And in particular that you want to discuss, any thing. Listing chat is just a code. I do have a couple of sites I want to share with you guys tonight too. I hope that'll be interesting. I hope. Yes, we're going to go ahead, guys, and start. So before I start, I'm going to go share my desktop as you have gotten used to now, and I'm going to be sharing my desktop. There you go. Okay, I'm going to go minimize a few things here. Minimize a few things. My email, you don't want to look at my email, huh? Okay, so with this, let me just go ahead and so I can see you guys. So I'm going to grab as I go through these, put over here. Also, what I need. Okay, so I'm going to go ahead and basically go over what the quiz is. 92 of you guys have got this one armor cable. This is, you know, this is what we call it the fixture web, and I can see, guys, over here. This is a fixture web. You are allowed with an MC cable, an NM cable, and a bunch of other cables, guys. You are almost allowed 6 feet of no support for to a fixture for the most part. What we call it fixture web. So 6 feet no support fixture web. You got it right. The second one, FCC cable. You guys read it, all this stuff. They don't want you to use it in residential hazardous locations. So the most accurate. The closest to the accurate is basically on damp floor. Damp might have confused you. It's not wet. It's damp floor, but it's smooth. Our sound smooth and continuous. So that's kind of the type FCC can be installed on damp, smooth, and sound floor. Most of them were right too. MC cable is permitted to be. You can. This is the king of the kings in terms of cables, guys. MC cable. You can use it as a surface. You can use it as a branch circuit. You can use it as a feeder, direct buried. Believe it or not, MC cable, if it has a jacket approved for direct burial, you can use it as direct buried. So that's probably one of the things that maybe confuse you. But if it's approved, which some of them are, you can do that, boy. This one confuse you guys. If you have a UF cable, a residential application, branch circuit, 120 volt, 20 amp, GFCI protected, this you don't need more than 12 inches. That probably confused some of you. If I'm going to grab my pencil here, and if I say here's my 20 amp, basically 20 amp, and the voltage here is 120, as you know, 240, just 20. And this circuit breaker, this is a circuit breaker, got a GFCI circuit breaker, and I went all the way to my garage here, and I fed my garage with the garage underground. Then I have to, then the depth here doesn't have to be more than 12 inches. You can make it 12 feet if you want to, but no more 12 inches. Exactly, this is very specific, again, in residential. This is a residential, very specific application, guys. Question about this? I see that 5% of you. Question, guys, about this? That's for confuses you. It's special application from table 305, I believe, 300.5. All special application for residential only. Any questions, my friends? Any questions? I don't see he has any question. Dan, my friend? No. Basically, special application. Let me say this one and get out of that. Okay, that's, I don't know if that confuses you or not. Moving on into armor cable without insulated equipment and conductor. About if you look at all the applications with the commercial garage and blah blah blah, it can be fished in air voids of masonry walls where there is no excessive moisture. Swimming pool, no. Picture studios, no. Commercial garages, no. So the most appropriate one, as you can see, is 8. Moving on into number 6. Number 6, some of you guys get it wrong, is a definition of an AC cable. If you look at AC cable, it's a cable is fabricated assembly of insulated conductors, 14:1, wrapped with an impregnated paper and so forth. So if you guys read, my email is popping up here. Read all this description. Basically, it's an MC cable. So that is, AC cable. Any questions? I don't know why you got that wrong here. Any question about the definition of an AC cable? I don't know why 62 got it right and the rest got it wrong. That should be a straightforward definition. Missing something here. Cable. Armor cable, guys, must be secured by approved things within 12 inches of a box and a cabinet. Some might ask, Chad, how about must be secured every 4.5 feet? Well, it depends upon the size of the cable. Not all of them 4.5 feet, but depends upon the size of the cable. So that not be true all the time. 4.5 feet. So it's not true. So that's the most accurate one, as I said, is that's why 54 of you guys got must be secured every 4.5 feet. MC cable, if the big cable, could be secured at longer than that, longer distances than that, and you guys can refer to MC cable if you don't believe me. So any question guys about this one? Any question about this particular one? Question about this one, the support of the support of an MC cable, and you guys can review for MC cable support. I'll get that one. MC cable securing and supporting. If you do 330.30 MC cable securing and supporting, unless otherwise permitted, a cable shall be secured at intervals 6 feet. So you can get, that's the advantage of that. Structures containing 10, so a smaller conductor, you have to support them every 12 inches from a box, smaller, which is number 10 and smaller. Support them every 6 feet. So 6 feet is the most common application for it, and 12 inches if they are just small conductors. So that's the of an AC cable, the MC cable over AC and NM and so forth. Any question about AC cable? Probably that's what confuses most of you on Conduit 54. Mid-clad cable is not permitted. MC cable is not permitted. In direct buried under any condition, no, you can bury it if it's rated for that. Be installed in corrosive location, regardless of the type of the construction protective covering. No. For service, no, you can install them for any one of these. Outdoor, if this is the wrong one, outdoor, and I know probably get confused. Look at the covering is interlocked armor type without an overall jacket. If it's an outdoor, it has to be wet location rated. So you have the overall jacket like watertight, conduit and so forth. So that's basically one based on the application. Now, if you were to install it in a wet location like outdoor, it has to have an overall jacket. Any question about this? Any question? This one, I see where the confusion can come to be. No? Okay. Jay, my friend, I can see you. Hand up. Let me pass the mic to you. Go ahead. Yes, is your mic? You can shift to talk.
All right. Yeah, I can answer. It says to be installed in corrosive locations, regardless of the construction of the covering, that it is permitted.
All of that is permitted. Second, to be installed in corrosion location, regardless of the type of the construction or protective covering. The protective covering has to be rated for corrosive location.
Well, yeah. It says it's not permitted.
Yeah, metal cable is not permitted to be installed in corrosive location, regardless of the type of construction. Excessive corrosive here is excessive corrosive emissions. But I can see your point. I mean, we have overall covering. Let me see. I'm looking at MC cable here. Use is not permitted. It says we're subject. I'm looking at 2008. We're subject to physical damage, constructive. Okay, but it's very clear. It says we're exposed to any of destructive corrosive conditions in A or B unless the metallic sheet or armor is resistant to the conditions. So I can see buried, like unless the buried, direct buried or exposed to cinder fells and so forth.
I guess the confusing part we're saying because it's not permitted, you know.
Yeah. So, yeah, it could be permitted if it's rated for it.
Yeah, but it says
okay.
Regardless of the type of construction. So.
Yeah. How many of you have thought about it this way? How many of you have? 19% of you. How many of you have read it this way? As installed in corrosive location, regardless of the type of construction or protective covering. And you know what? I can see, Jesse, you know what the issue is. In 2008, they changed it and they allow you to do it. I mean, it says supposed to any of the destructive corrosive conditions A or B unless they have an unless metallic sheet or the armor cable is resistant to the condition or is protected by material resistant to the condition. So this unless. So I can see your point though. I see your point. 2008 uses permitted, uses not. For the purpose of any okay, we're subject to ambient temperature. Okay, this is looking at
and as it can be direct buried where it's identified for such use, so I can see the point to answer A also.
Yeah. So metallic.
It says you can use it for services also, so even that one's right.
Metallic cable, MC cable is not permitted as for service.
Yes, it says 33010 A1. If you
but MC cable is not permitted for service. That's not true, right? It is permitted for service.
Yeah.
Yeah. And to be directly buried under a condition, any condition, that's not true. It is. See, the negative. I think that's what's getting us up.
That's
the negative. Yeah. So B is right, but we're saying it's wrong. You know what I mean?
Yeah.
Hope that makes sense.
It's got like two right answers in there.
Yeah, negative. Okay, Jesse. I'm gonna do my friend here. Okay, comments, guys. Great one, but it's that negative is so D continues to be good the answer based on the negative. So what we're saying in D here is we're saying we can't install it, but yes, you can install it. Move into number 9, MC. MC cable would need its own fitting, so you can't go borrow an AC cable or an NM cable or flex cable, conduits, and use it with it. So that's all of you guys almost got it right. So above, you cannot use the fittings of a different cable with an MC or any cable. Every cable has its own associated fittings, guys. So NM cable, guys, you can use it in multi-family dwelling, 1 and 2 family dwelling, store, and office. You can use it in any location. It says if you use it in what is it? 1 and 2, I remember, you have to put it under 15 of fire-rated walls or floors or ceilings. So above, but we use it in residential, and we can use it anywhere else. It's better in wood construction building. But building is non-wood construction. You still can put it in behind wall rated for 15 minutes. I see why all of you guys did that one. Almost all of you did it. Type SC cable. If you guys, the options here has a moisture-resistant covering. That's the only accurate one. It says may be used for underground application. No, that's a USB cable. That's number 11. Number 12. Underground feeder and branch circuits cable. Cable may be used for interior wiring. The UF cable. Interior and installed as a non-metallic cable. So we're talking UF cable. You can use it inside, treat it like an NM cable in terms of construction and so forth. So everybody got it almost right. Hammer cable is permitted to supply volt amp, all the voltages. A cable is the king of the kings. You can bring any voltage to it, no problem. Number 14. For part, you have to maintain 1.25 inches from the cable. When you drill a hole in 2x4, you have to maintain 1.25 inches between the cable and the edge of the 2x4. Everybody got one right. 10 to 15, code permits cable to install where exposed to physical damage. None. If you install a UF cable and physical damage, you have to put it in a rigid, or you have to put it in a PVC schedule 80. You just install it. So everybody got one right. Type cable. All of these pass through a space where all these cables, guys, I don't know why you cut. So if you have an NM cable, AC cable, SC cable, they're allowing you to go through the cold air return as long as you go perpendicular. And you don't go across, you go perpendicular. So that's okay. They have to pass through the space which serves a cold, not return in dwelling. Provide cable is perpendicular to the long dimension of the space, perpendicular to the long dimension of the space. Dimension of the space. Any questions about this one? So all cables. Any issue, my friends? So moving on to AC cable. AC cable, you have to support it at 12 inches from a box and for enclosure of box. And the rest of them, guys, the radius of bend for AC cable and NM cable, both of them are 5. So then a quick review of what we have done, and go ahead and return you back into my PowerPoint presentation. Any questions, my friends? Anybody have any questions? Any questions? My friends? Oh, guys, kind of that if cables, you know, you got something. I'm sure a lot of you guys use wirings with cables all the work. But tonight, we're going to switch guys into wiring with conduits, and feel free to jump in. A couple of things to help me here wiring with conduits. Move into wiring with conduits and the advantage of wiring with conduits. I'm going to move through all these quizzes. I load them, but I like to go over my Excel sheet, guys. It's easier. Okay. So here's the conduits that we're going to be going over, guys, my friends, tonight. Number one is, let me ask you guys, how many of you have used ENT, electrical non-metallic tubing? How many of you guys used ENT, non-metallic tubing? Use it? Okay. So here's conduit number one that we're going to be discussing, guys, tonight. Another conduit, notoriously famous, and this notoriously famous conduit that you use all the time is EMT. EMT is like Bomix when it comes to conduits. That's the conduit you're going to use all the time. And C is the second conduit. Let me just a couple of things, guys, before we go into the conduits, and just give you my 2 cents in that. If you are under, let me just instead of under, I'm going to say wet location. If you're wet location, if your location, you are PVC. If you have a dry or damp location, dry, slam location for the most part, location, probably was going to be EMT. That doesn't mean you can't use EMT in a wet location, by the way, you can. But for most part, the best application for EMT, my experience, my understanding is EMT, dry, damp location, mostly dry. PC, these are your conduit of choice for wet location, underground, outside, especially direct buried. So that's basically your conduit of choice when it comes to wet. And you guys feel free to inject your opinion here. These two conduits, IMC and rigid, you really don't want to use them unless you have physical protection and they have physical protection. And or hazardous location. These are the moment places that you're going to be using physical protection, severe physical protection, and hazardous location. You really don't want to use a rigid or EMT just because. So these are the two conduit of choice you can use in, as I said, physical protection to protect the conductors from physical damage and hazardous location. Feel free to guys inject your ideas on that one. Now last one, ENT. ENT, I have seen a lot of two applications for ENT that I've seen. If you have well, ENT is a non-metallic conduit, electrical non-metallic conduit or tubing. It's limited. It's non-metallic, so it's in non-metallic, guys, is great in corrosive environment. So if you have a corrosive environment, ENT conduit would be, almost think of it as PVC, almost PVC, kind of, in terms of application. Wet location, highly corrosive environment, PVC, ENT conduit is going to be there. I've seen an application for it one time where they need a lab, a chem lab, and they don't want interference in the lab itself, so they want the whole lab with ENT, so they don't have interference with chemical equipment, electronic equipment that control the chemical process. So that's the situation that I've seen where ENT does not act as an antenna and bring noises and interference to your electronic equipment. So that's the application. Any comments, guys? Anybody has anything to say, disagree, agree with kind of what I've said? Anyone has raised his hand or her hand and talk about their experience with it? I would love to talk about ENT, guys. Where do you use ENT? Because in PVC and ENT we use them all the time. Anybody want to say we use the ENT? You chat it with me if you don't want to talk, and we'll try these days. No, feel free to chat your experience, especially with ENT, guys, because it's not commonly, at least experience with it, not commonly used conduits. So these are the conduits that we're going to be talking about tonight. Before we go into conduits, guys, I want to bring to your attention two different types of conduits you're going to be encountering. Number one is metallic conduits, and number two are non-metallic conduits. And Jacob, my friend, if you are in a highly corrosive environment, like direct buried, like wastewater treatment plants, oxidation ditches, lift stations, chemical plants, and all these places get certain chemicals that eat through metal, like steel and so forth, and aluminum, your conduit of choice probably would be a PVC, non-metallic conduit, like PVC or ENT, depending on the application. If you have a highly corrosive environment, which is mostly wet, doesn't have to be, so that will be your conduit, non-metallic conduit. For all other application, guys, your conduit of choice probably will be a metallic conduit, and most likely would be 90% of your time probably would be an ENT. Any disagreement, any correction? So but probably percentage, what I can put here, 90% probably of what we do, we can get away with EMT conduits. When you're ground, probably 90% of your time is going to be PVC, schedule 80 or 40 will get you there. Any comments, guys? Any questions? Nope. To mention these are not the only conduits that we use. RTRC conduits, which is another type of like underground conduits. I have a couple of other conduits, but these are the most common conduits, guys. Encountering basically, I have RTRC, which is, and if you guys install RTRC, it's like a PVC conduit, mainly for underground. So that's, other than that, the ones you guys are looking at are the ones that we want to mention and go over. Flexible. I can't emphasize the word non-flexible conduits. We're not using flex in this case. Okay. So these basically your options. Non-metallic conduits. What's the advantage of? These are a couple of reasons, and feel free, you can add more reasons or to why I use the conduit over cable. You can argue, guys, a lot of people from an installation point of view, argue if you do your conduit right, if you're good with conduits, it might be cheaper conduits than cables. Though for the most part, probably if you are to wire a whole building with MC cable versus AC cable, it might take you less time to wire with MC cable. But if you conduit right, you might break even, as I always say. How many of you would rather use an MC cable or AC cable versus EMT, if you can? How many would rather use an MC cable, AC cable over a conduit? And again, there's advantages, guys, and disadvantage of using cables over conduit. We engineer, now putting my engineering hat on, at least the project I worked on that I've seen, we will specify like home runs will be conduit to the first box, and after that we'll leave it up to the contractor to use a different cable, MC. But always kind of specify that we want you to bring the run up to here with a 4x4 deep box, and then from here, and you can bring a home run. That here, you can multiple home runs, guys. And from the first J box, and you argue where do you want to put the J box, guys, and you can then conduit system that you want, an MC cable and so forth. So by doing it this way, guys, it allows me, as you all know, it allows me to pull new home runs in the future if I to the first box in ceiling, which is most likely going to be in the ceiling, so I can spread with a C cable where I want to go. So that's kind of a hybrid between cable versus conduit, complete cable versus complete conduit. So I always say, at least you need your home runs to be conduit with an EMT or a PVC that's underground all the way to the panel. And after that, you can use an AC cable or MC cable. Okay, advantages of using conduit. Run is exposed. This is a major advantage, guys. If you have an exposed application and you use an MC cable, you know how smart You can be Joe, my friend, but you cannot get the MC cable to get straight. You can spend as much time as you want, but the MC cable or AC cable cannot get 100% straight. It doesn't look good. You can get very close, but really doesn't look as good as a conduit. So that's that look. The look if it's exposed location. When damage here, physical damage, just exposed. The ceiling is exposed. Look is an issue. An EMT conduit will look much better. Could that be replaced? This is an advantage, definitely. That's why a lot of engineers specify at least a home run, guys, to be conduit. You can add and replace conductors, add for future expansion, replace conductor, a burned cable, or current couple of conductors. You can pull them, you can replace, you can add, you can do some work, serious work on it. So that's an advantage of, as you know, the conduit. Advantage obviously is physical protection. Definitely, MC cable does not provide as good of protection as an EMT conduit, or rigid, definitely not as much as good rigid. As a matter of fact, we can put an MC cable inside a rigid sometimes, or PVC to pull them for physical protection. So that if you need a physical protection, definitely a conduit as an EMT, special EMT. If you don't have a severe physical damage, if you have a severe physical damage or severe physical protection, you're going to go to, as we know, rigid intermediate or PVC 40. So that's an advantage. Generally, let's use damage during construction. I guess you can argue with that. Doesn't get as much damage because cable could be easily cut through and damage the conductor and so forth. Another advantage here, guys, conductor with a special characteristic can be used. I can use high temp conductors, high temperature instead of 90 degree, 150. I can use. You can use a lot of advantages. So the cable. I guess now with the cable manufacturers, my friend Dan, they can make any cable with any characteristics that you want. But for most part, if you have a conduit, you can pull conductors of different temperature. You guys have used, let me ask, how many of you have used a high temperature rated conductors, like 150 to 150, high temperature rated for special applications? If you high temperature location, very hot environment, and you need to with the heat, your cables can get the temperatures very hot. So application is to use, instead of a 90 degree rated cable, you can use a 150 degree rated cable, and these are Celsius, by the way, or 150 degree, and I think they can go 300 even. So that these conductors is easy to pull them right through a rigid or EMT conduits. And the major advantage, well, not a major, but a very good advantage, guys, as more conduits can provide low impedance to ground metallic. And this is just an advantage for metallic conduits. I can't emphasize this is only for metallic conduits. If you have metallic conduits, you do not need an equipment grounding conductor. So you can get away without an equipment grounding conductor. EMT, rigid, intermediate, metallic. If you have a PVC, this advantage drops, because if you have a PVC, you still have to pull the equipment grounding conductor. Any questions about the advantages of basically conduits over cables? Any questions? So you can argue some of them. Now, advantage of conduits, they are not hard to work. They need more skilled labor to bend them. More time. You can argue this too, to support them and bend them the right bends and so forth. You can't fish an EMT for the most part. You can fish conduit. You can argue one too, but for the most part you can't fish a conduit. But a cable is for the most part it's easy to fish a cable. So they're heavier. If the rigid, the conduits are heavier. So that's kind of more expensive for those parts, conduits versus cable and so forth. And again, 6 of one, half of another, guys, in terms of applying it. But I would say at least if I have my choice on my projects, I would say at least the home The horns will be in conduits to the J box, square J box, 4x4 or deep square, and then from there I can allow the contractor to use MC, AC, or any other conduit cable, or full conduits, as a matter of fact. And any questions? Then we do, guys, tonight. Go back a little bit. What I'm going to be doing, we're going to be going over the ENT, IMC, rigid PVC, and ENT. Just going over article, a couple of things that you need to know about. A lot of these things, guys, are as you read through these 4 or 5 articles, they have almost the same thing, and you're gonna hear me reading myself for PVC rigid certain things. Continuous metal raceways. If you guys remember, metal raceways are used as an equipment grounding conductor. They're used, my friend Dan, as a ground. If there is a ground, then you have to make sure the continuity is maintained and not compromised. How to guarantee that the continuity of the metallic system is compromised? You have all your lock nuts, connectors, couplings, fittings must be secure, tightened to ensure the low impedance of ground. If you have a lock nut or if you have a connector that's loose on a 4,000 amp switch gear and you have a short circuit and short circuit goes through that loose, for example, the impedance back to ground will be so high. Who cares, Chad? You Eric message, Chad. Who cares? Well, who cares is your circuit breaker is supposed to trip within 3 cycles. It might take 6 cycles. Okay, who cares? Still, who cares, Chad? What cares is half of the switch gears will be burned before the circuit breaker wakes up. Don't care. I'm talking about if it's a major switch gear, $500,000 switch gear, you're going to go burn that switch gear because of a loose connector, and I'm just exaggerating here, or loose lock nut on a ground fault or a short circuit. So this is all has to be tight to ensure that your equipment, a grounding conductor, is the best loaded to ground, meaning the current will go as fast as it could back to the source through the conductors back to the source, if not to clear it. Loose connectors, here's a couple of, if you have a loose connectors, what's going to happen? You're going to create heat, arc, and spark. And all these guys, you might have a loose connector forever and nothing will happen, ever. And only happens if you have a short circuit or a ground fault, which we could, because loose connectors and the system is working and you don't have a ground fault or a short circuit, nothing will happen because that conduit is not carrying any current, right? It does carry current, the conduit. The conduit and the connectors, and couplings, and the lock nuts will carry current only if you have a short circuit or a ground fault. And for the part is the ground fault. We'll take the ground fault current all the way back to the source. Any questions? Any questions? So that rule applies to all the conduits. All your conduits, regardless of the metal conduits. Things, guys, about raceway, and you have the seals and the drains, which is temperature. So we have to have. Why do we have to have moisture seals and drains? Important to prevent moisture. Why do we care about moisture? Because it accumulates in the enclosure, and if the moisture accumulates in the enclosure, what happens? It turns into water, and all of a sudden you have a dripping water right above your 200 amp, 225 amp panel. So by from sealing the conduits, especially when it goes between two, as we all know, if you have a conduit coming from outside to the inside, you're going to seal your conduit. As you seal your conduit, you're going from like to it's going to be, or a couple of days, it's going to be minus 13 here. And if you get inside, probably most of the application, you're going to find it, what, 72. So from minus 72, there will be condensation. You prevent that condensation, guys, and the dripping of water right above your equipment. Okay, a couple of things, guys, about the seal. So seal for environmental, when you go between two different temperatures, outside side is the most common one. plugging this way ends with a duct seal, and we're talking about duct seal compound. And what's going to happen? Prevent the moisture air, which can create condensation, which creates dripping right above your switchgear. That's the main reason, guys, why we put a duct seal and we seal the conduits as they enter. Okay, I do have. Can you hear me? Can everybody clear and loud? Can you hear me clear and loud? Can you hear me clear? Okay, it seems everybody's hearing me, my friend. For your mic. Okay. So that, guys, sealing with two different temperatures because of condensation and dripping of water. Moisture seals shall be located where there will not be trapped condensation and raceway. So in a location where you don't trap the condensation in raceway, and you get drains. If that's to happen, you have to have a drains, as we say, little holes in the conduits where the water can seep directly in. Let me see here. Thank you. Okay, so we're going to seal first, and when we put our seal, we're going to put the seal in a location where if we have from coming over here and going, here's outside, inside, and I put my seal. This is my fittings. I put my seal. I'm going to make a little seal over here as I enter the building. I'm enter the building here. You're going to allow a little hole here where it can, the condensation of water. And that could be from also not just in out, guys, also from water drain to conduits coming from the top to not to enter this. You're going to be sealing over here. So whatever water comes in is going to out of the conduits. And what the seals, moisture seals in the drains. We're going to seal as we go between two temperatures. You have a drain. If the moisture traps location, you don't want to trap the condensation water in the conduit. Otherwise, you have to have whole conduits can go. And there should be an open. There should be an opening, draining fittings, or a hole at the bottom of the fitting or enclosure at the low end of the raceway. And that's what we're talking about. If you're coming conduit down over here and going all the way up, and then you're going to have, I'm just showing over here my conduit, and we're sealing. So whatever comes, you're over here as you enter, and any condensation, any comes into this conduit will seep right outside this conduit. Any question, guys? I don't know if that's the right example or, but how many of you seal enter? How many of you have used seal conduits and fittings and drain holes and so forth? You use it more than I use it. So pay attention to that one as you go between different temperatures. Okay. A couple of things, guys, and this is going to be talking about metallic conduits. We have the rigid and the intermediate. These, as we all know, we can thread them, and we talked about them. They're threadable, which means you can thread them. We use them for physical protection. It's used in wet location, but not highly corrosive environments. Not highly corrosive. I can't emphasize. Wet location means on the roof, but like underground. Even though you can bury the rigid metal conduit guys underground, it's not meant to be buried underground. I can't emphasize that. And hazardous location, bring it on. Industrial location. So these two conduits are mainly for physical protection or this location, and the physical protection happen a lot in industrial plants. You have forklifts running everywhere. You have trucks hauling things everywhere. A lot of machines moving from A to B. You do not want any machine or forklift to hit a feeder or a branch circuit or a service that can drop the whole 2,000 amp switch gear circuit breaker. Drop it, and then you lost power for the plant. So that's basically the one main application of the one, as we all know. See, guys, EMT is thinner, nicer to use, lighter, cheaper, and carries more conductivity. conductor. So that's basically the advantage, the only advantage of IMC. Unless you have severe physical, some of them are rated for severe physical protection. And if you have an industrial plant, guys, where forks are up and running, everywhere trucks, and you have a service and feeders, I always go by the rigid metal conduits, not the IMC. So if you, the way you look at it, even though both of them are rated for physical protection, RMC is the top physical protection that they can use. So rigid obviously is heavier. The disadvantage of rigid is heavier, bulkier, harder to work with, harder to bend, as we learned before. But in return, you can have a fork running right into it, and most likely will handle a fork running into it. So if the one can handle it. Any questions about these two conduits? I mentioned that for the more light rigid, guys, you can get it from 1/2 inch up to 6 inches. IMC, if I remember right, you can get it from 1/2 inch all the way to 4 inches. So that's kind of a disadvantage of IMC. So if you're for a rigid 5-inch or 6-inch rigid, you're not going to find it. I mean, IMC, you're going to find it on rigid. Anything guys about rigid and IMC? Any questions? Okay, so the advantage, guys, both are good conductor shields. Both can be watertight if they're used in a wet location. Both have rusting. This is the one I want to emphasize. And emphasize, guys, yes, you can. Oops, that's not a good choice of highlighter. Yes, you can use this conduit, guys, outside in a wet location, even though you can bury that conduit. You can bury it rigid, but they're not meant to be. Rusting is a big deal. So if you are to use the conduits underground, I always say a lot of engineering rules, guys. You go underground, you're using a PVC. You're using a PVC. Anything else about this? The drawback of this, it's rusting. There's a few types of rigid metal conduits, guys, as we go through it. That's some of them are super when it comes to grid brass and stuff that you can use it right into into a swimming pool. Very highly corrosive, very high weation, and still work. Rigid brass or red brass, I think they call it. Okay, a few things about the rigid before we go into the electrical non-metallic tubing. Any questions, my friends? Any questions before we go into the electrical non-metallic tubing? So for non-metallic tubing, so what we're going to be doing, guys, with these articles, we're going to just go over electrical tubing, look at that particular rating system, advantage, disadvantage, where can we use it, where can't we use it, and just keep moving, guys. And I have the NEC code book here up and running. So you guys said they used the particular one. Here's what we brought definitions, guys, just because related to concealed and exposed when it comes to electrical non-metallic tubing. If it's concealed, this is rendered inaccessible by the structure or fish of the building, or fish of the building. So if it's concealed behind walls or ceilings or floors or wall, ceiling, or floors, basically. Why? So that's what concealed, as we all know. But that's right from the definition. Concealed is basically behind walls, permanent walls, ceilings, or floor. Permanent walls, ceilings, or floor. Thing is permanent, Chad. We can bust it. I understand, but these are not removable panels. So, but a couple things, guys, about concealed, and that's the reason why we brought these, because it's related to the ENT. If you have it inside the conduit, even though they're concealed, they're considered accessible because hollow. So that's just keep in mind in that one. Wires inside the conduits, wires in concealed raceways are considered concealed, even though they may be accessible by withdrawing them. They are considered concealed, even though I can pull them. Even though you can use if I can pull them, but you can't pull the conduits. You can pull them, but you can't pull the conduits, I guess, if it's concealed. Keep this in guys. Why the conduits are considered concealed? Exposed. Exposed on or attached to a surface, or this is the most important one, behind panels designed to allow access. False ceiling, raised floor, panels on the wall that you can open and remove, not commonly used, but for the most part is raised floor or suspended ceiling. Anything on walls or behind raised floors or panels considered exposed. Let us guys understand the ENT exposed and concealed in a second here. Okay, ENT, this is your ear, nose, and throat doctor. That's how I always remember it, as ear, nose, and throat doctor, my ENT doctor. Here's finding guys, it's non-metallic, very important. So the thing that comes to your mind, my friend, if you see non-metallic, always remember these are great for a corrosive environment. Anything non-metallic, guys, the first thing comes to mind when I hear non-metallic, great for corrosive environment. The second that comes to my mind when I hear non-metallic is no grounding conductor. And the third thing that comes to my mind, if you're going to use it in a ceiling, return plenum ceiling, they have to be plenum rated conduits. Because plenum ceiling, anything, you don't want to use anything in a plenum ceiling that's not plenum rated. And for the most part, we use the EMT because if you have a fire, you don't want to contribute to the smoke, the spread of the fire, the spread of the smoke. So the first thing comes to my mind when I hear the word non-metallic. The thing, guys, pliable. When you hear the word pliable, it's easy to move it. This is, we're not talking about EMT here. It has the advantage of the PC metallic, but pliable. You can move it easily. Corrugated, and it's a raceway of circular. It's not rectangle cross section, so it's a circular with integral or associated, and so that's basically it. It's raceway, and it comes with its own associated couplings, connectors, fittings for the installation of an electrical conductor. And why do we use it? Like everything else, we're not using it, guys, to carry water or gas. We're using it to carry electrical conductors. And emphasize, guys, the definition of these wire system is very important. Understand what the definition is. Non-metallic means great for corrosive environment. Pliable, easy to work with. Most of them are circular, and all of them have their own associated fittings that you can use. And just mix and match. Okay, composed material that is resistant to the moisture, and the advantage of it, and chemical atmospheres, and is flame. The other advantage of it, guys, everything put non-metallic in a building, they always want it to be flame retardant. They don't want you to fill the whole, the whole building with flammable things. So all these conduits that's non-metallic, they want to make them a material where it's flame retardant. It doesn't contribute to the spread of the fire and the smoke. At one time it will, but they said for a certain amount of time they will not contribute. And the whole building will be engulfed with fire, and they don't care, I guess. Any question about the definition? The definition is very, very important to find the ENT. So what is of a conduit are we using? What type of conduit are we using? Again, the pliable, easy to work with, guys. Okay, and I will do it to a break in a second here. Let me just go over this one. Use is permitted. This is where I want to go over, guys. When I use it. Building exceeding 3 floor above grade. So that's kind of the first drop of that conduit system. Though they have an exception. ENT permitted only with walls, floors, and ceilings that have a 15 minutes finish rate. Building exceeding. So up to, my friend Eric, up to 3-story building, residential, commercial, industrial, and you can use that boy, no problem. Concealed or surface mounted, no problem. Concealed or surface mounted or exposed, no problem. If you go higher than 3, then it has to be you put it basically concealed behind walls. Well, it has to be behind walls, floors, or ceiling, and it has to have 15 minute finish rating. 15-minute finish rating. So when they test it, fire rated for 15 minutes. Fire rated walls, ceilings, or floors for 50 minutes. So above ceiling materials that would be provide 50 minutes. The same thing if it's either behind or above suspended. So if you go higher than 3 floors, then they want you to put them behind either concealed or exposed. But exposed, they have to be behind removable panels. That's 15-minute finish. How many of you guys have installed the EMT in higher than 3 floors? ENT. How many of you guys have installed ENT higher than 3-story buildings? 3-story buildings. So there. Now, use is permitted in a city 3-story building. I don't know if I have it on the second slide here. Okay, so that's basically up to 3 buildings, exposed or concealed, no problem. Bring on. If you go more than 3 buildings, you have to put it behind sheetrock walls or behind suspended seat that rated for 15 hours. Minutes fish, the way I understand it, I'm not a fire expert, it will take 15 minutes for that particular wall to catch fire, like a 1-hour rated wall. I think it's a truck to qualify like this. 15 minutes rated, 15 minutes wall. Means it takes 15 minutes. Somebody can jump in and correct me at any time. Exactly, JC, my friend, what I'm going to go after, the sprinkler system. That's the advantage you can go over. You cover in 15 now. They also have, if you have a fire sprinkler system, if you build a sprinkler, then you can go as hard as you want and you don't have to conceal it. It says where a sprinkler system is installed in accordance with the NEC2011-Ch standards for the installation of blah blah, the ENT shall be permitted to be used within floors and ceiling, exposed or concealed in building exceeding 3 floors above grade. So ENT shall be permitted to be used within walls, on walls, within walls, floors and ceilings, exposed or concealed in building exceeding 3 floors. And there are 15-minute rated walls, fire rated walls. Is identified as a listed fire rated assembly. Listed fire rated assembly. 15-minute rated thermal barrier shall be permitted to be used for combustible or non-combustible walls, floors, or ceilings. Okay, so most part, my friends, concealed or exposed 3 floors or less, more than 3 floors, either you conceal them with 15-minute fire rated wall, or you have to sprinkler the whole system. You have the whole system. I mean, sprinkler the building. Any questions? Any comments about this one? And I'm looking at page 210 in 2011. Above 3 floors, basically you have to conceal them. Put them above, removable floors or ceilings, guys. That's considered, well, it's not concealed, but shall be permitted to be used within walls, floors, or ceiling, exposed or concealed. If it's sprinklered. Otherwise, if it's not, for 15 minutes behind walls. Okay, I see a chat here. With the terminology, I haven't used it honestly. So there's a lot of trade names that for this, a couple of trade names that they use. Smurfs, but they use the word Smurfs. Okay, Smurf pump or Smurf tube. I have those terminology that they use it. I'm not familiar with other things, but coating, that's a whole lot of different idea here. Rigid covering coating. I'll talk about PVC at the ones. Okay. What you mean now? I'm familiar with the term that you use. Thank you. How about this one in a second? But ENT is not PVC coated rigid. Okay. Any question about the ENT? A question about the ENT? So you need 3-story, no problem. You move it up to higher than 3-story. Either you conceal them with a 15-minute rated wall, or you sprinkler the system and you still have to conceal or expose them, as a matter of fact. Behind walls, conceal, expose. How a conduit, guys, behind walls, concealed or exposed? If it's concealed, as we say, it's going to be behind permanent walls. If it's exposed, then it has to be removable walls, like false ceiling and so forth. So, and sprinkler system shall be permitted to be used within walls, floors, or ceiling, exposed or concealed. If it's within a wall exposed, that will be removable. And if it's concealed, then that wall or ceiling or floor will be permanent, basically. Okay, any questions, guys? I want to come and I'll give you guys a break in a second. Where the advantage of it? Where can I use this baby? In concrete. You can bury it in concrete. ENT. But so you can put it in concrete, but make sure you don't crush it. Get crushed or pulled from the connectors. So good application, guys. Directly buried in concrete is a good application for it. You pull conductors, pay attention to crushing and being away from the fittings or the boxes and so forth. And also, like a conduit, guys, you do not want to have, it's a nightmare to pull conductors in this conduit if you have more than 4 quarters. So make sure you don't exceed the 4 quarters. And if we're in a concrete, it has to be, as you all know, must be listed for concrete. So that's application. Uses permitted. Places of assembly. ENT shall be used in buildings used as places of assembly where the building code does not require fire-resistant construction. It's going to be my conduit of choice for places of assembly, but you're going to check that one as a big question mark on that one, guys. Places, restaurants, camps and meeting rooms in hotels, chapels, places of assembly. If, again, building code does not require fire-rated construction. Anybody ever used them, guys, in the places of assembly and restaurants? Anybody ever used them in restaurants, church, chapels, conference meeting rooms and hotels? So this is not permitted. Where can't you use them? This is you're not conduit of choice for hazardous location. There's always exception in the code, guys, intrinsically safe system and so forth. Support, how are you going to support? This is a conduit, this is pliable conduit. You can't support anything. Conductors or cables operating at, we're subject to ambient temperature. We're subject to ambient temperature higher than what 122 on this listed for the place. In particular one, guys, has been changed in 2008. This number 4 has been changed in 2000. They allow you to use a higher temperature rating than what the conduit is rated for if the ambiguity of the conductors are rated for the temperature of the conduit. So they changed number 4. The ambient temperature is still 122. You don't want to exceed 122. This is rated for that. And I see your hand, my friend. Emphasize number 4. They change it. For example, if your conduit, guys, is let me give an example of this. If this conduit is rated for 90 degrees, and I decided single to the chat carefully to go put conductor inside it, and conductor is rated for 150 degrees. 2008 you can't. In 2009 you can. The only condition is the conductor amps cannot be more than 90 degrees. So if the conductor amps that the conductor can carry to the temperature of the conduit. So they changed that one to 2011. Okay, I will pass the mic to my friend Gerald. Head.
Mike keeps cutting out on me.
Mike? you can't hear me?
Time. You might be able to sentence and it'll cut right out.
Okay, I'm sorry. Okay. Me too. Oh, okay. All right. With my my one more time. Thank you. Let me I want to give you guys a break for a second here. Can you guys hear me now? Everybody can hear me clear? Everybody can hear me clear and loud? Okay. Okay, I just keep playing with my cables right here. Maybe I stop playing with the cables. See. Okay, one. Thank you. It seems one. Everybody can hear me, guys. It seems now. Maybe I'm playing with the cables over here and busting it. Also, what we're saying, guys, the temperature, they changed this one though. They changed it where the conductors, you install a high temperature conductor in an NT as long as you limit the ambiguity of the conductors to temperature of the conduit, which is the conduit. This is permitted again. You can't vary direct variance in the air. Limitation of the voltage, that's nothing to sneeze on, guys. Voltage up to 600 volts. That will cover 208, 120, 480, 277, blah blah blah. All these both location except as permitted, and we know where it is permitted. You can't, which is basically up to 3 phases in features, blah blah, except as permitted. If you go there, they'll get you exposed to the direct sun again, unless it's identified. That's what I hate about the code. They still know, and then they say, oh, by the way, the manufacturer have found the lube. Identify some of them as sunlight resistant, then you can use them. And can definitely subject to physical damage. This is not your conduit of choice to protect you from physical damage. Size, I'll give a break. Let me just finish this one, guys, just to move to a different. Any question about these? Any questions about uses not permitted? I can answer from it. No problem. And this is the sizes, limitation on the size. Look at that. This is not your 6-inch rigid metal conduit that you can use. So from 2 to 2, nothing to sneeze on, but it's limitation on the size. 2 to 2 limitation. If you go to table number 1, chapter number 9, which we will visit, you can find how many conductors you can fit, and also if the cable is allowed, you can find how many cables you can fit. I emphasize, Joe, my friend, you can put cables, multi-conductor cables in a PNT or a single conductor cable. A single conductor cable is called conductor. A multi-conductor cable is called cable, right? You can fit both of these, single conductor cable or multi-conductor cable, in the conduits. And where do you go to find this? You're going to go to chapter 9, which we will be visiting lately, guys. Bends, again, tubing, you don't want to damage the internal diameter of the tubing, will not be effectively damaged. And radius, the bend for the radius, guys, will be other. If you guys remember when we did conduit bend and so forth, we see bends. 2 chapter 9 will tell you the minimum radius that you can bend. These are pliable, so it's not, but you don't want to cut it too sharp like this. Your minimum radius that you bend this boy without basically damaging the conduit. And this is table 2, chapter 9, which we'll visit as we go through. Now, bends, guys, everything is 4 quarters, which is 360 degree. A conduit system that we'll be using, guys. You cannot bend it more than 300 degrees. Otherwise, you have to put okay, as you cut it, you have to trim inside and outside, remove the rough edges. You cut it because you don't want to damage the insulation of the conductors. Almost all conduits you're going to find it trimming. Almost conduits. How you fasten this boy shall be fastened at intervals of every 3 feet. Shall be securely fastened every 3 feet from a box, a device, a J box. So you have J box over here. You go 3 feet and you put your stable. You go another 3 feet. You put your stable. You continue. So my first 3 feet. Here's my 3 feet. Cabinets and so forth. Exceptions where you fish that boy. You don't have to. This is a conduit system, but because it's pliable, you can fish it. Then you don't have to support. Then you don't have to support it. Okay, so every 3 feet intervals and every 3 feet from a box. let's see. Okay, where tubing enters a box or other enclosure, the bushing shall be provided to protect wires from abrasion. I have a nice, I think, a nice picture, guys, for you. Talk about where you need a bushing to protect your conductors, and you just hold your. We'll talk about where do we need bushings to protect conductors as they enter the box, what size, number 4, and so forth. This is coming for the most part. If your conductors enter a box, you need some, not a smaller conductor in this case. For the most part, you need to protect from. You need to protect. You need to protect the conductors from damage. Which is number 4. Yeah, number 4 or larger. Number 4 or larger, you need a protection. Number 4 or larger. All between the links, blah blah blah. Tubing rings shall be approved methods. When you join all these stuff, you can't just go custom design and hot glue them together and cover it in. There's hot gluing together. You have to have everything is listed, fittings and so forth. Grounding. Drawback of this conduit, guys, non-metallic. So as you pull your conductors inside conduit, you have to make sure that you accommodate for a grounding conductor. So here's my phase A, phase B, phase C. I grab my neutral. Again, the color not the right colors, but you guys will ignore that one. And also I bring my equipment grounding conductor. Accommodate for your equipment grounding conductor. Drawback, but hey, it's a good. Okay, I'm gonna stop right here, guys. 2 things. I'm gonna give you guys 5 minutes break, and I'm gonna put the poll number 11 point. Just put the poll for you. So as you finish it, I'm gonna open it. It's let me see how many. It's 5. So I'm gonna give you options 5. Okay. I'm gonna open poll. Go ahead and finish it, guys, and we'll take a break. And take your break here. I'm going to go back. What time is it back? Let's say 12. Let's say at 7:20. 7:20 will be good, guys. Okay, so now at 7:20, guys, you finish that. So I hope they'll give you 8 minutes to finish and have a break. I have things I'm going to cover, guys, today. So, and go ahead and take your break, and we'll reconvene at 7:20. Okay. one. Can we just check? I know it's for you, but I have a few things to go over tonight, guys. Okay, if you can check in, guys, when you have a chance. All right, thank you, my friends. The set of this, so we talked, guys, about the ENT. It's not you come in, use conduits, use them I've seen them used in a place where you don't need interference. Yes, that's kind of a good application for it. Direct buried in concrete, another good application. Okay, on to the most, the other ones, guys, is basically the intermediate and the rigid. A couple of things, guys, about the intermediate and the rigid. We're going to put them together. So we have zinc coated or galvanized rigid, if we talk about rigid, and intermediate conduits to prevent the rusting. The drawback, here's what I'm going to, the drawback, guys, of this type of conduits is always rusting. So what they do is they coat it to protect that steel, especially steel or aluminum conduits. They coat them to protect them from rusting, and as you use them in a harsh, highly corrosive environment. That's basically the drawback of the conduit. This is a threadable conduit. I'm going to go, guys, and I want you to look at the definition of the intermediate. It'd be interesting. I'm going to highlight a few things. I want you guys first to highlight the word steel. So it is a steel conduit. Very clear. It's a steel conduit. The thing I want to highlight, so it's not aluminum, it's not any conduit, it's a steel conduit. It's threadable, so you can thread it. Raceway, cross-sectional area designed for, again, right at the for physical protection, routing of conductors or cables for the, and look how they made it very clear to, and used as an equipment grounding conductor. So that's very important. So you don't need an equipment grounding conductor when installed with its integral or associated couplings and appropriate fitting. I emphasize that it's a steel conduit. You can thread it, as we all know, mainly for physical protection, and it's an equipment grounding conductor. Very clear cut about IMC. Any question about this? Very clear. No aluminum, there is no brass, there is no any other conduit. It's a steel conduit. Done. And guys, some of you will say, what's wrong with that steel conduit? Well, there's other applications that you might need other than steel conduits. Like if you have a steel, guys, versus aluminum. Aluminum is very light. If you have an indoor application, aluminum rigid would be very nice because it's not heavy. Look, so I want you guys, a lot of people, because they're mixed up, a lot of people don't pay attention to the steel at the beginning. If you look at the conduits right here, I want you guys to see the word steel. Do you see any steel in it? There's no steel. Very important. This one says steel, so it's a one metal type only. The second one says threadable, so it doesn't say steel. Could be any others. Aluminum, brass, or any other type. Raceway of circle of blah, physical protection, bring it on, route the conductor, and also equipment ground conductor. The difference between these two conduits really is one of them is steel, or one major difference is one is steel only, the other one could be a conduit, as a matter of fact. I know that, like you go to a conduit, you can have red brass rigid mill, you have aluminum, you have galvanized steel, and stainless steel rigid mill conduit. There are 3 types, 4 types actually, furrow, raceways, and fittings. Okay, so aluminum rigid 3, aluminum, brass, red brass, and galvanized steel, and stainless steel rigid. So basically 3 types of rigid versus RC is only 1 type. Very important, guys. And generally, look at the word, generally made of steel, but it doesn't have to, of steel with protective coating, always protective coating because of rusting. These are any metallic object is going to be rusted. I can emphasize the word steel in IMC, guys, and steel in rigid. So very important. Use is permitted. This is first we're looking at for uses permitted is completely different, guys. The IMC for rigid, and we're looking at both of them. Uses permitted. I'm just going to look at the IMC here. It is for all atmospheric conditions and occupancies. You can use it. So it's superior. You can use it almost everywhere. Corrosive environment, no problem, but you have to make sure that it's protected for corrosion. Steel, coated steel, protected for corrosion. Can I put it in cinder fill? No problem. Can I wet location? No problem. Wet location. All supports, blah, 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 have to be corrosion resistant material. So it's really, you almost can use that conduit anywhere. So basically, the application for this conduit is permitted, and you don't see any it is used is not permitted, as a matter of fact. So it's really superior. Any application, any use for the 340.10. The only difference in 344, guys, the rigid is for, I don't think we have the uses before we do the sizes. If we go to the rigid, and this is 193, here's how they split rigid, guys. They have galvanized uses permitted. If you have galvanized steel and stainless steel, shall be permitted under all atmospheric conditions. So if you have rigid stainless steel or galvanized steel, anywhere you want. If you have red brass will be permitted to be installed for direct burial and swimming pool application. That's a superior red brass. You can. How many of you guys have used red brass rigid? Anybody have used red rigid? Any? So red rigid, if you have to have a feeder or branch circuit going right in the swimming pool or a fountain or something, you can use red brass. I mean, there's no corrosion, nothing. That's why it's direct burial and especially swimming pool. So there are times that you can use it for swimming pool and direct burial. You still can use stainless steel in direct burial, but if it's direct contact with water, the brass would be your conduit of choice. Also, they make an aluminum conduit out of this. Shall be permitted to be installed where judged suitable for the environment. You know, environment, aluminum is not friendly with corrosive environment. So rigid conduit, in case concrete or in the contact with air, shall be provided with approved supplementary corrosion protection. They make one of these atmospheric conditional coverage. They make aluminum, guys, where you can use it basically as long as you can use it in corrosive environment as long as it's treated. But really, the most part it's used for non-corrosive environment. In corrosive environment, look what they list exactly the clean corrosive environment. You can use galvanized steel, stainless steel, red brass, red, and all the elbows and all this good stuff with it. You use aluminum if it's protected. Aluminum if it's protected. So kind of here, wet location, all supports, bolts, blah, blah, blah. If you're using it in wet location, not only the conduit, they have to be wet location, the bolts, the supports, everything that goes with that conduit has to be in wet location. So they're basically the major difference between rigid and IMC. The sizes, different types, as I said, red brass and steel and aluminum type of conduits. Question is, any question about the two uses? Any questions before we go into this? As you can see, it goes from half. If it's any limitation, here's another limitation: that steel conduit only up to 4. It can take you all the way to 6. So you can buy a 6 rigid conduit, steel or stainless steel or red brass. Structures, exactly the same location, guys. If you go to table number 9, chapter 9, and see, also, if all the conductors are the same size, you can go to NEC and tell you how many conductors you can fit in a 3/4-inch rigid. The same if the cable is allowed to be installed in conduit, you can find how many cables you can install in a conduit. You treat the cable as one conductor, as a matter of fact. Any questions? And these, by the way, this will repeat itself for all the conduits I'm going to discuss tonight. All to chapter 9 to find how many conductors you can do, and I can go there with you. Bends, when you don't want to damage the interior diameter, and what's the minimum bend, radius bend that you can do. You go to table 2, and if you guys go to table 2, there's one shot and segment one shot. If we do table 2 there, and other bend. So depending how you bend it, you're going to go to conduit or tubing, one shot and full shoe benders. If you guys remember that, one shot and full shoe benders, and that's most of the time going to be with rigid. And so, and if you're 71, for example, if I have a 6-inch conduit, the minimum radius, that I can use is 30 inches. And I bend this conduit, and we talked about bending conduits, guys, in order to damage it. So if I have a 6-inch here, I need 30 inches radius to that baby. And this again from Table 2, Chapter 9. Any questions about the bend? No? More than, again, can't go back all the way. All conduits, guys, when you add the 90 to 90 to 90 the 90 here, I guess we probably exceeded it here, the 45. 9,950. This should be directly, this should be direct, how we're going to do that, coming right in here to make the system work. So you guys can see that. So before 90s, we have more here. We're going to do what I said. Ignore just the 45 here. Why would you? So 90, 90, 90, 90, 490s, 360 degrees, perfect. 490, 360 degrees, perfect. No more than that one. Any conduit, not this conduit, any conduit. Same reaming and threading, very important. Cut and shall be reamed. I'm sure I've done a lot of these. And reamed and finished to remove all rough edges. The worst thing that could happen is you leave the rough edges, pull your conductor, you lost the insulation, you short it. In the field, if you're using shooting in the field, here's the sizes that you have to adhere to, and that's directly from the code. Cutting die with a taper of 1 inch steel or 3/4 of an inch per foot shall be used. So don't mean to be a conduit. Where a lot of you thread conduits, these are restrictions on the type of the threads that you can use if you were to thread it in the field, which we do. Any comments about that? Reaming, threading. These are your conduit of choice when it comes to reaming and threading. Supporting. Securing and supporting us, these different because they're big boys. So securing and supporting these conduits, especially, I mean, IMT rigid, if you guys shall be installed as a complete system, and it will be securely fastened based on this. If you guys go to 342.30a, I don't know if I have a spot to this. Okay, this is just coupling. If you guys go to 342.30a, securing, it says you have to secure it every 3 feet of every box. Permitted to be increased to a distance to 3 feet of every box, blah blah blah. Shall be permitted to be increased to 5. Where structural mirrors does not readily permit fastening. Where approved, conduct shall not be required to be secure fastened 3 feet of the surface, blah blah. So for the most part, you have to every 3 feet of every box. Or you have to support. And levels of what? So this is my 3 feet. And after that, guys, support and support. For the most part, every 10 feet, there's some restrictions. Every 10 feet, between support, blah blah. You can go expose vertical up to 20 feet, and so becomes there's some center runs of IMC support. Opening through a framing, blah blah blah, not exceeding 10, and securely fastened 3 feet of terminal shall be permitted. So for part there's 310. That's what all that you for MC it's 310. I want to pay attention to guys C with unsupported raceways. In 2008 they said if the conduit's 8 inches or less, you don't need to support it. In 2008 they got rid of this. In 2007, guys. So, for example, if you have a conduit, that's very important. They just got rid of this in 2011 and brought it in 2000. So if this is an 18-inch, this 18-inch you don't need to support it. They got rid of it. The reason behind this, guys, if you have 18 inches, then with that, if you're 18 inches, you already supported. So here's box 1 and box 2 supported here, and you're supported here. So you need it up to 3 feet, right? So 3 feet you don't need support because you are you're supported with these boxes. So we got rid of the 18 inches, or so if you have 18 inches up to between the boxes, you don't need to support them anyway because you're supporting at the box right in here and right in here. Any question, any comments guys about that? So they give the 18 inches if you see 18 inches for wood and intermediate. So it's 310 with options. Another thing is I want to secure that I'm going to go directly to rigid. The use of the rigid has a table. So up to 3/4 every 10 feet. If your conduits are 3 or larger, they allow 20 feet. If you have a rigid conduit, 3 or larger, you can go 20 feet between the supports. That's kind of it's rigid metal conduit. It's very important. You can go 20 feet, guys. The whole table for it. During every 3 feet, they can go up to 5 feet. Fastening shall be permitted to be increased to a distance of 5 feet where structural members does not readily permit fastening at 3 feet. So most part every 3 feet. So if I have a conduit box over here, my 3 feet for the most part, that and conduit having to be a 6-inch conduit, then I can go 20 feet after that. If it's a quarter of an inch, 10 feet, and there is 12 and so forth. And there's some exception if you go vertical, guys, riser 20 feet and so forth. For this part, the thing 310, you have a bigger conduit, you have longer distance. In 3 feet, no support is needed. Yes. More than 3 feet, no support is needed. That's how you see if it's 18 inches, support is needed. Keep supporting. IMC shall be installed as a complete system, blah blah blah. Securely supported. IMC shall be securely fastened every 3 feet of each outlet box, J box, and blah blah blah. So if you're fastening on both sides, then you don't need to support. Any questions, guys? Any comments? Any questions? So the support, there's different things in the support. These guys, they can get with connectors and couplings. You can get threadless, and you can get threading ones. This shall be made tight. Everything in concrete, as everything else, they have to be concrete tight, concrete approval. Installed in wet location, they have to be rated for wet location. This one is interesting. Running threads shall not be used. Running threads shall not be used. You know, you have two conduits here, and you have some type of a coupling here. You have threads over here and threads over here. So the coupling can move this way and can move this way. You know, and how many of you guys have installed running couplings? You can move in either direction, this way or that way. The reason why they don't want you to run running couplings because you can't have them tight. You can get them tight to get a good equipment conductor. So running threads shall not be used. Running thread shall not be used. Any question, guys? Any comments about that? So with running threads installed in a running thread because their couplings can move in either direction. You can't get a grab. You can't get it tight in one direction. I have that picture here in front of me. You have to use it. Any questions, my friends? Bushings are very important. This is really a nice one. Bushings, guys, if you have to protect the conductor, these are bushing to protect the conductors. If your conductors are, let's start with terminals, bushings is required If you have a threaded terminal, guys, the bushing are always required. If you have a hub terminal, you don't need a bushing at all, a hub. If you have that threaded terminals, and if you have a fittings terminal, if you have a fittings, non-threaded fittings like this one, you need it only if the conductor is number 4 or larger. If conductors are smaller than number 4, then you don't need it. So permission number 6 and smaller, no bushing is required. I hope I have a nice picture here for you. But let me just review this one because these are really interesting. Let me repeat this one more time. So if you have a threaded, and I do have a nice picture here. Wish I could. So I have threaded couplings, guys. A threaded couplings with lock nuts. So this is threaded couplings right in here. See that thread right here? Thread couplings with lock nuts here. This one you need termination. Bushings always required for any size here. Now I have a hub. A hub I design, guys, it's smooth transition from the conduit to the box. You don't need the thing for any size. And if you have couplings like these are couplings. If a coupling and two couplings, not threaded couplings, just a coupling. And then if your conductor is number 4 larger, you need to protect it. If it's less than number 4, no protection is needed. And this, guys, for the most part, applies for all metallic conduits. Any questions about this? Any about this? Questions? I guess the hub is you've seen it in a mirror boxes where the conductors come over here and there's that little hub at the top. So it's smooth, nothing's gonna happen to your conductors, nothing sharp objects. But threaded comes like this with the lock nuts on both sides. That's the sharp. You have the edges, the sharp edges. You need to protect from all connector. But this is the guys with lock nuts on both sides. This is a fitting. If you have a connector with a fitting, then you only need it for number 4 or larger. Wing, guys, is like EMT basically. If you have a what's called a non-threaded, so basically if you have a non-threaded a thread coupling, threadless coupling, non-threaded coupling, that you will be in this application here. So based on T application. Any questions? My friends? But I hope I did not put you guys to sleep. Okay. Well, I'm going to go, guys, and so that's all what I need. I can't emphasize that rigid and EMT are a web grounded conductor, so don't forget that one. And that's all basically what we have about this. So, guys, if you don't have any questions, I'm going to give you my second poll for the night, which is how many questions are these? 7 questions. I'm going to give you 5 minutes. 5 minutes would be good enough, and we'll go ahead and start. Thank you, my friend. Okay, let's close it. Let's go ahead in a second here. Okay, I'm gonna guys go ahead and share just the correct answers with you, and you view them. I'm just looking at your answers. Simple, straightforward, and I can see that. Okay, let me see if that one. Okay, it's the code requirement for bushings for IM, C, and the original conduit containing conductors number 6 and smaller. And I'll answer this: metal or plastic bushings must be installed on of the conduit tension enclosures to protect the number 6 conductors smaller. See where some of you guys, if can answer where you don't need them. So long story short, guys, I know if you have conductors number 4 larger, you need an insulation bushings no matter what. If conductors number less than 4, less and smaller, then only need them if you have threaded connectors, not the threadless connectors, if that makes sense. If you have threadless connectors, you do not need an insulation bushing for conductor number 4, less than number 4, which is number 6 and smaller. So the real keyword is threadless versus threaded connectors. Threadless connector, you only need them for conductors number 4 or larger, like EMT, like an EMT and any other conduit. If it's threaded ones with knots, threaded conduit lock knots, then sharp objects are there all the time, then you need them for any size. I don't know if that makes sense. And any questions about that, rigid, before we into PVC? I don't know why we did it this way, but we will get back, guys, into the electrical metallic tubing, but I'm going to make a detour here, you Jesse, you're so right. Well, Chad, where does it say threadless? Yeah, where I'm the authority having jurisdiction. I want it threadless, Jesse. Okay? I can see your point here. Where does it say threadless? Unless it's still you threadless, it's always threaded connectors. That's kind of the assumption. Because we use that intermediate, guys, because of the threading. Unless they tell you really, unless they're going to use threadless connectors, the assumption is used. Let me ask you, how many of you guys use threadless connectors all the time with rigid and intermediate? Threadless connectors. You use threadless connectors most of the time. Okay, less on that one. The assumption is if you have rigid, you take advantage of rigid. You use threading. Everything is threading connectors and so forth. So if you're using rigid and you use the threadless connector on it, you're basically treating an EMT. It defeats the purpose. It's kind of defeats the purpose of using rigid. And using in hazardous location, you have to use threading. You have to not. I think you have. If it's used in hazardous location, you have to use threading connectors. Okay, so thread. Okay. Thank you. Let's go, guys, to the PVC now. PVC is your conduit of choice if you're underground or in a highly corrosive environment, including wet location. Really is that's the beauty of using PVC. Highly corrosive environment, underground, which is basically could be highly corrosive, or wet location. That's where rusting is the major advantage of PVC. It never rusts. That's basically is how we define it's rigid, so it's not pliable like the EMT. It's wrong. It's rigid. It's non-metallic, so any problem with rusting is out the window. Any problem with corrosion and rusting is out the window. It's circular. Almost all of them are circular. It comes with fittings and so forth. and it's also for conductors or cables. Very important, guys. If I want to highlight one thing, I highlight the word rigid and non-metallic. These are the beauty of the PVC. That makes it good conduit. What's that, baby? I'm looking at the PVC article over page 197. You can consume it, no problem. Corrosive environment, that's the reason why we have it. Corrosive environment, cinder, no problem. Wet location, bring it on. Dry location, that's much better even. Exposed, yep. Ground, that's why we invented that, good boy. Support of other conduits, yes, there's some restrictions in support of fixtures and so forth, but for the most part, you support other conduits with it. Use is permitted. Location and so forth. We got that one, concealed, cinder, wet location. Exposed, we underground, support of other conduits shall be permitted to support blah blah blah, but is not larger than. There's some restriction how big of a size that you can support for the part you can. So as you can see, it's superior. You can almost use it anywhere. The disadvantage, guys, here's the it's not as superior as rigid. Has location for the most part, no. Support of luminaires, they don't want you to support luminaires from that. Boxes, yes. Luminaires, no. So support for the support of luminaires or other equipment not described in part 2. They refer you to 5210. So you support up to a limit, guys, and so forth. But for the part, this is not luminaire type of conduit. Physical damage. Damage, guys, PVC Schedule 80 will get you physical damage, but PVC itself, schedule, as we all know, there is a 40 and the 80. The 80 will get you protection from physical damage. The 40 will not get you protection for physical damage. We're subject to physical damage unless identified for the use. And if you guys say unless identified for the use, then that's where they identify it by 40. Insulation temperature limitation. Insulation temperature limitation, guys, we're subject to ambient temperature of more than 22, and see it in similar locations. As you can see, they don't want you to spread the fire and spread the fire. So a couple of things, guys. Insulation temperature limitation for cables operating. This particular one changed. This particular, guys, one changed. Conductors, okay, rated temperature higher than this, the temperature shall be permitted for PVC. It actually used to be an exception, and they added it. So long story short, you can use 150 degree rated conductor now. AC conduit rated for 90, as long as the amps coming out of this cable are taken at 90 degrees. So it's operating at no more than 90 degrees. What and that's when they brought it from the exception into the use is permitted. Is that right? So this, look how beautiful. You can go from half all the way to 6. Big conduit. You can use it at any time. Conductor, guys, how many conductors can fit? Always from table number 8. And less cables, how many cables? Multi-conductor cable, always from table 1, chapter 9. Any questions, my friends, about how many conductors you can fit in this? NEC, well, if all the conductors are the same. With conductors, you guys gonna go NEC. If all conductors are the same size, type, insulation, but different, then you're gonna go to table number 5 and table number 4, and these are in chapter. All this stuff is in chapter 9. And we'll be visiting these guys as you go through and some calculation based on them. But same thing, guys. You don't want to damage the interior, and only bins identified shall identified for the equipment identified for the purpose shall be made only. You can't create your own vendor, and you're going to use the one-shot and so forth in the radius, as we talked about that with that one 360 degree which is 4/4 is the maximum they can go without a J box. You have to trim inside and outside and get rid of the rough edges, otherwise you're going to damage the conductor, right? You guys use rigid all the time, you need how PVC, it's not rigid PVC, it could damage the insulation if they're rough edges. PVC should be installed as a complete system. You can't just halfway through and pull your conductors and jump to shall fasten. So then movement from the thermal expansion, these are interesting. You have thermal expansion. So it fastens, so the movement from thermal expansion or contraction is permitted. Shall purely fasten, and they have the support. Let's go with the support, guys. Just securing and support of conduits every feet, basically every feet and at intervals every 3 feet. Generally speaking, they hold a whole lot of. So generally speaking, guys, if here's a box, about 3 feet and 3 feet after. So the first 3 feet from a box, 3 feet after, and you continue. If you have conductors, larger conduits, this feet, guys, can go all the way to 8 feet. The conductor, or if you have 6-inch every 8 feet, you have 5-inch every 7 feet. If you have 3-inch, 6 feet, 2-inch, 5 feet, and they have all range, guys. And I'm looking at table 352.30. So feet of every box, and then the 3 or 5, 6, or 7, or 8, depending on what size of conduits you have. So it goes all the way up to 7. Drop the 18 inches, and some of you guys ask me, Chad, what if you have a box here and a box here, and you have a piece of conduit between them? Right, this conduit is supported through the box here, supported box, as long as it's 3 inches, 3 feet or less. You do not. That doesn't mean you don't do it. You don't provide it. You do not need a support right in here, guys. It might be an idea to provide a support, especially if your conduit is small, like 1/2 inch or 3/4 inch. But I guarantee you, if your conduit is 6 inches, you really don't need it. 4 inches, 5 inches, 4 inches, 3, 4. I higher probably than 2. The waste of time to do it. You don't need a support. But does it look good if you do it? I'm sure it's no good. You need it? No. So they dropped it in 2011. It used to say 18 inches. Less. It makes the people feel that if it's more than 18 inches, then you need a support. That's basically it. Expansion. Expansion is very important. It says if you have an expansion of 1/4 or more, you need to have an expansion fitting. An expansion fitting. And whole table, guys, 352.44, very important. If you put T table, this table can give you the expansion fittings that you need. And here's the expansion fittings. And you can size this expansion fittings. You can size this expansion fittings. And let's look at temperature. Let's look at Minnesota 25 below. I think I did the example. Fahrenheit. And take it all the way to, say, 110, right? Fahrenheit. So that will be 135 degree Fahrenheit. If you take 135, that's a range from the. If you have conduit outside in Minnesota, PVC above ground installed, which we can on a roof or something, and you need to find the expansion fitting, so take the highest temperature 110. I don't know if we need 110 or ever reach 110, 285, right? So 135, did I do my math right? And if you guys do 135 Fahrenheit, 135 Fahrenheit give you 5.48. So it will be 5.48 for the next standard. So by a 5 inches, of course. So you're right in here. That deal here is going to be 5.48 or the next standard. Anything else about this? That's how we size. This will probably in your journeyman exam, as I said. Any questions about fittings? And that's directly, guys, from table 352.30. So 52.44. 352.44. Right here. conditions based on the highest temperature and lowest temperature. Temperature and lowest temperature. Where conduits enter the box, guys, the bushings that you need to protect, the same bushings. We need to provide protection for wires. For this type of conduits, you need the protection for if the conductor is number 4 or larger, So if you are number 4 or larger, you need protection, insulation bushings for protection. If it's less than 4, you need it. Doesn't mean it's not a good idea. You do not need it. You do not need it. Okay, and I'm going to keep moving. And it's asking me to keep moving, Chad. Joints between the lengths. Okay, conduit fittings shall be made by approved methods. You don't custom design, glue it, hot glue it together. No. A ground, guys, you need equipment grounding conductor with the conduit if it's needed. If it is, I'm not going to go where it doesn't need, but for the most part, 99.9, we need an equipment grounding conductor. Okay, with this, I am going to give you, my friends, any questions before I give you my second full night, and we come back, we do EMT, and we're almost done. Any questions about PVC? I can't size the PVC superior when we go underground. That's basically the reason why, or what should hide the corrosive environment. Okay, I'm going to mention, guys, PVC coated rigid. PVC coated rigid metal conduit. We installed some of this, guys. It gives you the advantage of rigid metal conduit, very robust, and also the advantage of PVC being you can install it in highly corrosive environment. So we installed this in wastewater treatment plant closer to oxidative ditches and so forth. So it's a PVC coated rigid. It's rigid and a PVC jacket right all over it. We installed conduit, guys, PVC rated PVC RMC, high corrosive environment that needs also physical protection. With them. I'll go ahead and open poll number 3, guys, for you, and I know you do to a break here. It's 5, so I'm going to give you open it. Then start. And what is it, my friend? 8:00. Okay, let's get back at 8. Let's get 8:15. We'll do it for you. A break and finish the poll. We should be able to be plenty of time for you guys. Okay, you can check him, please. Friends. Okay, just looking at different things here, multitasking. What we're gonna do, any questions, guys? I shared the answers with you. It's straightforward. The only thing I'm gonna mention, guys, is when it comes to PVC. Before I leave this topic, I just sure you are all familiar with PVC. There are two types PVC. The type that we use is free PVC and PVC 60. 80. And this PVC 80 has physical protection. That's the only difference. If physical protection, you go for 80, and if you have you don't need a physical protection, you go to 40. So if you're underground and completely underground, there's no need to go for 80. And first, guys, they're all, if I can draw that one, they all have the same diameter, interior diameter, except that 40 is thicker. They thicker. So see how the interior diameter, I don't know if that's the same, but you can imagine that this is the same. So the 80 is thicker, heavier. So the same diameter, if I say that, the outside diameter is the same, but inside diameter is different, if I may say that one. So the same fittings, you can fit the same fittings, but obviously the 40 can carry more conductors. The 40 can carry more conductors than the 80 because the 80 is thicker. It's thicker. Over all the outside diameter is the same. Any question, guys? Inside diameter, different inside diameter between the two of them. One is thicker, the 80 used for physical protection of conductors. Obviously, if I have to choose between using a PVC Schedule 80 for physical protection or rigid metal conduit, I will definitely use a rigid metal conduit. Because we all know steel rigid metal conduit is you can bust the wall before they bust a 6-inch metal conduit. Versus PVC Schedule 80, you could easily run a fork into it. Talking about Chad kicking in his shoe with his shoes. Talking about some truck or something run right into it. Moving on into the single most important. We left the best, I guess. Electrical metallic tubing. If you guys, this is the opposite of electrical non-metallic tubing. It's a tubing. The reason for the word tubing because it's a thinner shell. It's a thinner shell. That's why I think that my understanding is they use the word tubing versus conduit. So electrical metallic tubing, the opposite of electrical non-metallic tubing that we just covered. This one, let's go directly into the definitions. Look at the definition. This is metallic, so it's out of metallic, so it's rusting is dry. So threaded, very important. It's an threaded thin wall raceway of circular cross-section area designated for physical protection. You can get physical protection. Very important, Eric. I don't know if you know this one. EMT can give you physical protection, but it cannot give you severe physical protection. Very important. The difference between physical protection and severe physical protection. If you have a severe physical protection, you're rigid or IMC. You need physical protection, like in Chad getting mad and just throwing a chair across the hallway and hits an EMT. That's okay. That's physical protection. But Luke is running right into that cable. That's severe physical protection. EMT will not provide a severe. It will provide a physical protection. Why do you use it? Not to channel water. It's always for conduits or cables. Us guys forget the word cable because you can have a multi-conductor cable inside the EMT. And it's also an equipment grounding conductor. Very, very important. It has its own fittings. You can't just go borrow any other conduit fittings and use it with it. So, to summarize, guys, it's a steel. So the advantage is it's used as an equipment grounding conductor. It's a metallic, mostly steel, and no threading, so you don't have to worry about threading it. And it provides some degree of physical protection, though severe physical protection. Where can this is the single most important, in my book at least, the single most important conduit they're going to be using all the time. Where is it? Can I conceal it? Bring it on. Can I use it exposed? No problem. Corrosion protection, use it in a corrosive environment, though it's not meant to, with treatment and in wet location outside, no problem. So, and it says, guys, ferrous or non-ferrous EMT like steel, aluminum, blah, blah, shall be permitted to be installed in concrete in direct contact with Mother Earth or in areas subject to severe corrosion influences were protected by corrosion protection and judged suitable for the condition. This is really not your wet location conduit, corrosive environment conduit, guys. It can be used if it's protected, but even if it's protected, it's not meant to be underground conduit, though you can use it. So all supports, bolts, blah, blah, shall be corrosive resistant material. Really, this is a conduit, guys, that's meant to be in dry or damp location and wet location above ground. That's really what it meant to be. And even in wet location above ground is not the best location for it. So that's my understanding of it. Comments, any questions guys about this? Questions, comments? Or I use it if Chad Curdy Suzuki is to drive right into it, that's called severe physical damage. You cannot use it to protect your conductors. Again, corrosion, it's a protection from corrosion only by enamel. You have to have an extra corrosion protection. Extra corrosion protection. You can use it in a highly corrosive environment unless you protect it. And cinder concrete, fill were subject to permanent moisture. Again, it's not your conduit of choice when it comes to corrosion, guys. This location, no. Some exception, obviously, I can use it to carry intrinsically safe system. Okay, conduit for intrinsically safe system. Some years there are some exceptions. Support your luminaires. Equipment, okay, conduit larger than largest size, blah blah. For sort of luminaires or other equipment, except conduit bodies no larger than the largest trade size, so you can support conduit bodies. Okay, that's basically they have an exception, guys. Here it says aluminum fittings and enclosures shall be permitted to be used with CMT. We're not subject to severe corrosion and influence. So if you have anybody use most steel conduit, but any use guys aluminum fittings with the EMT steel, and use aluminum fittings, EMT steel. So you can, as long as there's no severe corrosion influences. Basically, your conduit of choice. Here is the drawback for only 4 inches in eternity, but still drawback. Conductor sizing and cable sizing, guys, directly from table number 9, as we did. You don't want to bend it. You're going to bend it right based on one shot or full shoe directly from the minimum radius for bending that conduit directly from the table in chapter 9. Work that one. As you run it, the same thing, 360 degrees, or provide your own box or so forth. All cut edges of EMT shall be reamed, otherwise finished to remove. Otherwise, you have to remove the rough edges, guys, as we all know. Can I thread an EMT? Of course, you see it. Look at that. What does it say? Exception. Can I thread an EMT? Non-threadable. So if you guys go Article 28, 38.8 is EMT shall not be threaded, exception EMT with factory threaded integral coupling complying with 358.100, and if you go to that 358.100, it says factory threaded integral coupling should be permitted. With threaded integral coupling is used, threads for both the tubing and the coupling shall be factory made. Coupling and the EMT thread shall be designed so as to prevent bends of the tubing at any part of the thread. So I don't like to go there, but but as a threaded factory. Anybody used it? Anybody ever used it as a threaded with a threaded coupling? Anybody? So they can make anything for you these days, guys. But for the most, I just want to bring your attention to that exception. EMT with factory threaded integral couplings, and if you guys refer you to the 100 and it describes it there. Anyway, for the most part, no threading. This is not conduit that you thread. You can have a set of screw conversion connectors if it's outside and so forth. All right, securing. Secure port, guys, for the most part, it's 3, 10. So 3 from every box, cabinet, and 10 in between. So that's basically the support of that particular fixtures when it comes to securing and supporting. 10 feet, 310, 310 support. You can 3, you can take it to 5 under some exceptions, but for the most part, you're 3 from every box, and then in between 3 and 10 for the short secure port. This is all what I have, guys. The same thing, they drop the 18 inches. If you still look at the 18 inches, between two cut 18 inches does not need the support. They drop that one. Make them in runs of 10, though I'm sure they can cut them for you. 10 feet. Slices shall be made in accordance with 215 and so forth. Coupling. I can't emphasize that this is an equipment grounding conductor. This is an equipment grounding conductor. So that's the beauty about it. Questions, guys? Any comments about the EMT? EMT is your conduit of choice when it comes to commercial buildings and a lot of indoor dry or damp location, guys, especially dry locations. You're going to be your conduit of choice. And easy to bend, as you can have the hand benders as we covered a long time ago. It seems like last year at least. Okay, I'm going to go ahead, guys, and grab that pole for you. And pole number 4. And how many minutes do I have? I have 3. I'm going to give you guys 3 minutes here. That's good minutes, and go ahead and open it. Go ahead and start, my friends. Okay. Okay. Just a second here. All right. Okay, great guys. I'm going to share the answers with you. Not a big deal. It seems big action, dissimilar materials together, and so forth. Any question, guys, before I move into two things I have for you? Any questions about what we covered about an N-E-C2011-Ch? Make sure you get with me. Talking about chapter 9, guys, table 2. I'm just going to directly share my desktop and highlight chapter 9, in chapter 9, and NEC. After that, I'm going to show you a couple of websites, and we have a quiz and the quick quiz, and then we're done. So just for the sake of the time, share desktop monitor 2. Okay, here you go. Monitor 2 is up and running, and I'm just going to grab you guys so I can see when they ask you a question. I'm going to let this right in here so I don't want to see anything else. So okay, good. Chapter 9, guys, table, which is all about tables. Here's what you how many the cross-section percentage of cross-section area of conduit and tubing not exceed. One conductor or cable. If it's a multi-conductor or cable, you can't fill more than 53%. You have the most of the time, guys, you're at number 3 here. You can't fill more than 40%. So 60% of the conduit is empty for reasons: for heat to dissipate, allow heat to dissipate from these conductors, and number 2, guys, allow you easily to install these conductors and add to install these, basically to install them because of the friction and so forth. So, basically what they keep telling us, I want to highlight a few things here. These are very important, guys, and I'm going to highlight if I know where my, okay, where did it go? I have my here and grab my highlighter. Okay, I just want to, if all the conductors, guys, are the same, come on, pen here. Okay, if conductors the same, they send you directly to NEC. I'm going to go to NEC. I'm going to look at a few things. Here's the important one coming. If you have a multi-conductor cable, it will tell you treat the multi-conductor cable as one conductor, for the sake of filling. Like this one, guys, if you have, if we call it nibble, if it's 4 inches or less, you can fill the conduit up to 60%. Very important. A short conduit, 24 inches or less, you can fill it up to 60%. You don't go for 40%, as you can see here. The fourth thing, number 9 is for cables. Number 4 is for 4 inches or less. These are important. There is another one that I highlight always, number 7. Number 7, guys, if you end up with a calculation of points when you do conductors, so if you end up with so how many conductors can fit in 4-inch conduit? You did the calculation, blah blah blah, and you end up with 11 conductors and 11.8 conductors. That will make it 12. If you end up with 11.8, will add up. You go up to 12 conductors, but 11.7 you have to go down to 11 because you don't have 0.7 of a conductor. That's basically what this rule is. It's very important for journeyman license. So I want to these two guys in particular because they come very handy. So any question guys about this? Any question about these things? 3 things I did or 4 that I highlighted. How about next for chat? I can see you guys here. Number 6 and take a shot at it. All right. discuss that one. Okay. The second thing we keep referring to, guys, is the bending radius. This is that we get the bending radius. We use this one when we talk about bending conduits. So if I rigid metal conduit and one shot or shoe bend, I have a 30-inch. If I PVC conduit, other bends, which is 36 inches minimum radius before you bust that conduit. So that we keep referring to it. Guys, if your conductors are different type, and size, you have to use basically table number 4. Let me use a different color here than this. There you go. If your conductors are, this might not be my best perfect green. Okay, so conductors, guys, are the different conduits. Like, for example, I have 2 conductors, number 10, and conductor number 14, and a third conductor, and 3 conductor number 8, all in one conduit EMT. What size conduit do I need? So that's basically, you're going to be using table number 5. This is, you're looking at EMT. Table number 4, guys, specifies the size you can fill for all the conduits recognized by the code. So EMT, for example, I have 4-inch EMT and have more than 2 conductors, as you can see. How much can I fill out of this, legally fill out of this 4-inch EMT? I can fill up to 5.901 inch if I have more than 2 conductors. If I have a nibble, which is 20 inches or less, it can go all the way up to 8.852. You have the ability to fill more. If I have one cable, one type of conductor cable, I can go all the way up to 7.81, a little more. If I have 2 conductors or 2 cables, conductor cable, I can go all the way to 4.573. Question, guys, about reading. Any question about reading this table? That's how much I can fill legally if I'm to use an EMT conduit. If underneath it, here's the EMT, and if you look underneath it, that's MC, and it keeps going all the way through all the recognized conduits in the code. Important to know. And then this is what we call it, table number 4. It goes through all the conduits, rigid, EMT, flexible, blah, 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 all the tools. So that much I can fill. And then all the way to table number 5, guys. Table number 5 gives you the dimension of the cross-section area of conductors. Let's use, for example, and I'm going to go to, well, let's go back to table number 5. So table number 4, number 5, you can use it if the conductors are different sizes. So there you go. Let's say here's my table number 5. What's the cross-section area if my insulation is this CRR-HH, special insulation, and I'm using 4 and I am using 5 conductors, 4 okay? I decided to use 5 conductors, 4 and then here's the cross-section area of each conductor. You multiply this one by, well, let's make it even and say 10. I'm going to be using 10 conductors. Well, make up my mind, Chad, huh? I'm using conductors, guys, number 4. You multiply this by 10, then that will get you a 4.754 inch. That's the minimum available space that you need to fit these 10 conductors, number 4. If you go back to table, if you remember we were looking at EMT, I can get an EMT that can get me 4.574 or more. So basically you do the calculation for the conductor here, and then you can go to table number 4 and find under the 40% fill the size of that particular conduit that allows you to these conductors. Any questions, guys, about this? Any questions about this one? And we'll take examples as we go if you haven't chosen that. I can't highlight table number 5 and table number 4. You only, Eric, use table number 4 and 5 only if the conductors are different sizes or different insulation. If all are the same size and the same insulation, it will be waste of your time then to use table number 5 and number 4. Why? Because NEC will get you everything that you need if all of them are the same size. Okay, so now we use these tables, guys. And 7 snapshot. And I'm going directly, and the rest of them, guys, you can go here and you can see all the THHN, all the insulation types. I'm sure you're familiar with THHN. You're going to find THHN, the cross-section area. If you use how many of you guys have anybody ever used compact conductors? Compact conductors? Compact conductors, if you know the name, compact conductors. If you're using compact conductors, these are, you can get the cross-section area for them, guys, aluminum or cover right in here. They're not round, guys, and they basically have a smaller diameter with maps. So conductor, you're going to use them for retrofit only. You'd never use them for anything else. Okay. Table number 8 is very important, guys. We use it. Table number 8, we use it if your conductor is a bare conductor, uninsulated, covered, or bare conductor. Table 8, we will use this one for voltage drop later too. If my conductor is a bare conductor area, the cross-section area. So if I have, let's just take, I have a bare conductor here. Quick, grab a pen, and my conductor is bare, and I'm using. Come on, get me a marker. And I'm using 2 watts, and I need to find it's a copper, blah, blah, blah. Where's the cross-section? See the area here? Here's the cross-section area. And if it's a bare conductor, here's the cross-section area of 2 watts. Bare conductor is 0.137. So we have 4 of these bare conductors. Don't ask why, Chad, we have 4. You multiply this number by 4, and then go back to table number 4. And we'll tell you how many 4 conductors number 2 watts you can fit in an EMT conduit. Guys, any questions about that? So this table is used only for bare conductors, bare non-insulated conductors. Questions? Thing I want to show you guys here, NEC. If all the conductors are the same, you click on NEC, and here you go. You get yourself all NEC. NEC has EMT, all the conduits approved, and how many conductors you can put in them. If it has that little star asterisk next to it, as you can see, this one, this means it's compact conductors. The conductors are compact. We're able, blah, blah, blah. Okay, the conductors insulated must be compact. These are special conductors, small size, that you can use for retrofit. Okay, so let's just say EMT. Let's go all the conduits. Can you guys see all the conduits approved by the code? We'll find them. And let's just say one conduit. Let's just say maximum number of conductors or fixed wire in electrical metallic tubing, EMT. Let's see how many conductors, number 12, THN, can I fit in a 3/4 inch. Okay, here a 3/4 inch. Oops, why did you go there, Chicken? Let's go all the way. We're still electrical metallic tubing. I think we're still electrical metallic tubing. Let me just see if the okay, electrical metallic tubing, EMT. Yep. Go and find how many conductors. THN number 12. Can I fit in 3/4 inch? Can you guys see that? So very easy, straightforward, no gimmicks, nothing. You can, here's my, come on, my marker. Okay, here's my THHN conductor. Here's number 12. Need to know how many conductors of number 12 THHN can I fit in a 3/4 inch. I'm sorry. That chat here. Okay, let's go one more time here. Okay, grab it. Grab my marker. And here's my THHN. I need number 12 conductors, and I need to know how many can I fit in 3/4 inch. Here's number 60. 60 conductors you can fit in 3/4 inch THHN. If I want to say, well, I'm going to go how many number 1/0 can fit. I need 4 number 1/0. What 4 number 1/0? How many? What's the size of the conduit do I need for 4 1/0? Here you go, 1, 3, 4. Here's a 4, right? That's what I need 4 of them. What size conduit do you need? You go all the way up and you get you an inch and a half. Now, how about 500? If you have a circuit of 5 conductors, 500. 5 conductors, 500. I need a conduit for it, EMT. Here's a 3 here. No, I need, here's my 5. And if you go all the way up, that will get 3 inch. Very useful, guys. You can find the size for the conductors, the size of the conduit, or you can find how many conductors you can fit in a conduit, or what's the size of the conduit for certain conductors. Questions, guys? I want to show you, this is EMT, but you can find it for any other conduits. So coming down here, you can find it for EMT, ENT, rigid, and blah, 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 all the conduits, EMT, all the conduits that got created in the code. Here's my ENT. I want to emphasize, guys, there are 2 tables for every conduit system, one for compact conductors. So for this 1A, maximum number of compact conductors. Don't get confused. These are special type of conductors, specially designed to fit in smaller size. So you can fit more conductors compact in the same size conduit. This what I want to show here, guys. And then let me see. The next thing I want to show you before I you guys, you go to Granger and you can find all these conduits. I'm sure you guys are very familiar with it. Different type of rigid PVC, schedule 80, and so forth. Just give you a quick run through, and we've done that before. And different type of conductors. But the one I wanted to do is really, anyway, so here's all the type of conductors, so you can buy the price and so forth. I'm just doing a lot here. The second thing I wanted to say, I just, not this one, tubing, okay, all right, okay. Here's the ENT conduit, guys. ENT conduit, it comes in curves, as you can see, is 1,000 feet of it. If anybody will buy, guys, anybody's ready to buy it, is it 100? About 100 feet. We have a 100 feet of this ENT conduit, electrical non-metallic tubing, blah, 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 100. It's yellow, used for communication conductor fitting, blah, blah. This special type of conduit they can use it. So it's basically, I have just, I Googled and I came up with this site that we can buy, and a couple of fittings that come with it. First, I wanted to show you that particular one, this one, home. And any questions, guys? Any questions before I show you the last thing? And then go back. Any questions? How about the next? Make sure that you're good with me. I see your name here. You're not scared of Chad anymore. All right. Joe is there too. Okay. The thing I want you guys to look at is it has nothing to do with what we're doing. Before I have another poll for you to do. You know, all of you guys know that I teach in Conduit. So what I put on my YouTube, all my YouTube lectures, and if you guys can see, I put 51 videos on YouTube. 51 videos. Just you don't have to go there. So if you're interested, guys, I can't play them here because you can go there. I have a few of them right here about motor control, PLCs, the NEC2011, I mean, ambiguity calculation. Each one of these guys, it averages an hour to an hour and a half. So if you have nothing to do, then night you can go and watch one of Chad's lectures here. I think they're really good, guys. For those of you who want to get more info, I have something about estimation. I encourage you guys, estimation 1, 2, 3, and 4. Calculation 1, 2, motors, AC, air conditioning calculation, electrical wiring, residential, and more to come. Humps, how to use the ambiguity table, table number 1. I was teaching you guys the thing I did with you. I do it with my students. I'm done with it. But I just put it in YouTube format. PLC, we did a couple of jobs, PLC, wiring, motor control, NEC2011, and so forth. Anyway, there's 51 videos, close to 60 hours of lectures right on YouTube. All what you have to do, I'm going to copy this link, guys. If you're interested, I read the link right now, and I will send it directly to you. Link here, chat with you. If you're interested, just hit the link here. It's coming in a second for all of you, and you should be able to watch all or some of them if you're interested. So here, you guys should have received the link. Okay, I thought that's really interesting to if he's interested in this. If not a big deal. There's really good material there. If you guys have a chance to go over there, do me a favor. Could you please just give me a comment or two, if you can. If you can, it's not a big deal. One last thing. I have a 50. It's a 51. So I have one more poll for you guys. I need to do. One is 10 points. So I'm going to give you an extra. Okay, I have 8 minutes here, but it should start this poll, and that will be the last one for the night, guys. Go material, huh? There's a lot of good stuff. I know some of you guys have went to technical colleges. This is exactly what I do for my electrical design and construction students. I just put them online. So if somebody's missed a lecture or something, you can go back and review it. It's all non-filtered, not meant to, watch it. Remember, it's the real life things like I'm doing with you guys. So people are talking and joking and all this good stuff. Will benefit. So if we apprenticeship, you'll check out. Okay, so let's go to the last exercise I just opened it for you. And start, my friends. It seems all of you have started. I'll go guys close it. Seems all of you on. And all right, I want to go share the corrected. Just looking there at all this, it seems that it was about what's the minimum radius, guys, for rigid. You go to table. I see some of you got some of it wrong. You're going to go to table, basically table 2, chapter 9, like I just showed you. That's probably get used to that table. Otherwise, it seems everything is good. Questions, guys, about what we covered? Any questions about what we covered? Next for chat, guys, make sure that you're with me before I let you go. Okay, a quick reminder, guys, that we are done with semester number 1. So this is semester number 1. I have 2 books like I do. Semester number 1, we're done with this book. So make sure next week you have semester number 2, and you guys have something similar to me, to what I do semester number 2. So just a quick reminder to bring your semester number 2 book to the next week when you show up. And a quick reminder also that we just covered, we did cables and did conduits. Next week we're going to talk about raceways and wireways. Raceways and wireways, surface mounted raceways, metallic, non-metallic, wireways, metallic, non-metallic. So it's a really interesting topic for next week. And so that's all what I have for you guys tonight. Any questions before I let you guys go? Any questions? Any questions? No questions? Anything for me? That's all I have for you tonight. Thank you guys for listening. If you have a chance, look at my views and give me a feedback. By the way, we're updating it every day. I load new ones. My intention by the time we're done, probably going to have close to 150 videos. Maybe worth probably 2 hours or so, 2 hours. So that's kind of the intention. So yeah, enjoy it if you have. Drop me an email if you criticize or find something wrong. Thank you guys for listening to chat, and I'll see you next week. And thank you for the smiley faces.